Hi everyone, welcome back to 7.4. In this particular chapter or section, we're going to talk about how we can figure out how strong a solution is. Okay, and so we're gonna talk about the concentration of that solution, and we're going to actually look at how we prepare these. And so you may have seen some of these solutions that have been prepared or in some of your previous classes. So the concentration of a solution is the amount of the solute divided by the amount of solution, or the amount of solute per amount of solution. And so you can describe this several different ways. You can have a mass percent, you can have volume percent, mass volume percent, or molarity. Okay, so mass percent is grams over 100 grams, like we were doing before. Volume would be milliliters per 100 milliliters. Mass volume would be grams per 100 milliliters or liter, or these can change. Molarity is going to be moles per liter. Same thing as moles per 1,000 milliliters, right? So those are just different ways of expressing concentration and the units that we're going to use. So mass percent is like I said, this is important. Grams of solute divided by the grams of solute plus the grams of solvent. So when you do mass percent, you've got to make sure that you have the entire thing added together. So if you have, usually you're going to see grams of per 100 grams because that's a percent, right? And the way you do that is you are going to weigh out a solute, and in this case they have weighed out 8 grams of KCl, and then they're going to add water to that until it weighs 50 grams, and so that's going to give you 8 grams of KCl per 50 grams of solution, right? Because the solution is the 8 grams plus ever how many grams of water. So that way you can do the mass. So 8 grams of the KCl plus 42 grams of the water gives you the 50 grams total. So 8 grams of KCl divided by 50 grams of the KCl solution times 100 gives you 16% mass. A solution is prepared by mixing 15 grams of sodium carbonate and 235 grams of water. Calculate the mass percent of the solution. Go ahead and put me on hold and see if you can do this. So we've got 15 grams of the sodium carbonate, and so we're going to divide it by 235 grams of water plus 15 grams of the sodium carbonate that we put in there, okay, because we just mixed them together. So that's going to give us 15 grams divided by 250 grams, and that's going to give us what? 6%. So 6% would be our answer. 15 divided by 250. It's just the mass are the ones it's really important that you add that particular, add the solute and the solvent together to get the solution. The volume percent is just going to be milliliters of solute per milliliter of solution. All right. So and usually you're going to see milliliters per 100 milliliters again for a volume percent. The mass volume percent is going to be grams of solute per 100 milliliters of solution. Again, that turns it into a percentage. Alright, so in this learning check, they just want you to write those conversion factors. How are you going to get 8.50% mass? Okay, what does that give you as far as conversion factors for all these three? So what it's saying is that you've got 8.5 grams per 100 grams, but reminding us that we can write that either way, so we can flip that if we need to. 5.75 milliliters per 100 milliliters, so that's our volume. This was our mass. And then this is our volume mass, right? Or mass volume. Molarity is one that we use a lot in chemistry because remember, when we're doing reactions, a lot of times we have to convert to moles and know how many moles are reacting. And so when we do concentration, it makes sense that we'd be doing moles in so many liters or milliliters of solution. And so if you have 1 mole of a solute in 1 liter of solution, we call that 1 mole. So 1 molar, you'll hear people say 1 molar solution. Okay? So a 1 mole sodium chloride solution, you weigh out 58.5 grams of sodium chloride, and that is the molecular weight of sodium plus chlorine, because sodium's 23 and chlorine is 35.5. Okay, and that's where the 58.5 came from. So that's 1 mole. So that's how much sodium chloride you need to put. And then what you do is you have this special flask called a volumetric flask, and it's got a line on here, and you bring that liquid up to exactly that line, and that gives you exactly 1 liter of liquid. And so you've put your sodium chloride in there, and then you bring it up to 1 liter. So that gives you 58.5 grams in 1 liter equals 1 mole of the sodium chloride per liter. So that's how you do it if you were doing it in a lab. So there'll be questions about this in calculations. So what's the molarity of 0.5 liters of sodium hydroxide solution if it contains 6 grams of sodium hydroxide? Okay, all they're asking you to do is say you're going to have to convert it to moles, right? So you're given 6 grams of sodium hydroxide. So think about what we were talking about before, and then you're going to put that in 0.5 liters. Okay, so we got to know how many moles that is. So sodium is 23. Oxygen is 16, and hydrogen is 7, and so that gives you 40 grams in 1 mole of sodium hydroxide. So 6 grams sodium hydroxide times 1 mole over 40 grams, so that those cancel. It's going to give you 0.150 moles, and you've got 0.150 moles in 0.5 liters. Okay. So 0.15 moles divided by 0.5 liters gives us 0.300 m molar sodium hydroxide, which is exactly the same as saying 0.300 moles of sodium hydroxide per liter, okay, of solution. It's important that you remember that that is the same as this when you're working problems. So what is the molarity of 0.225 liters of potassium nitrate solution that has 34.8 grams of potassium nitrate? So put me on hold and work this so you can make sure that you can do it. You work it just like that example that we just did. Okay, so I'm just going to kind of go through it with the steps. So a mole of KNO3, and you know how we got that, is 101.1 grams. All right. So we we don't have exactly 101.1 grams. We're given 34.8. So in order to find out how many moles that is, we use the molar ratio. 1 mole is the same as 101.1 grams of potassium nitrate. So that tells us that it is 0.344 moles. And our volume is 0.225 liters. We know our answer needs to be in moles over liters. So that tells us what? That we're going to divide 0.344 by 0.225, which we do here, and then that gives us 1.53 molar potassium nitrate, or 1.53 moles per liter of potassium nitrate. You use molarity a lot as a conversion factor, and you can use, like you can be given, okay, you've got this molar solution, if you want to dilute it in order to have, a less concentrated solution or whatever, you can use those equalities to do that. These are just, some conversion factors, just kind of showing you, how you do that. That, if you have a 10% mass, you know that that's the same as 10 grams and 100 grams. A 12% volume is 12 milliliters and 100 milliliters. 5% mass volume would be 5 grams and 100 milliliters. And then they're reminding you that you can use that conversion factor either way, upside down, okay? And the same thing with if you've got a 6 molar solution, that's the same as 6 moles per liter, and you can also write it as 1 liter over 6 moles. So this is important to get your head around, because this is what you're going to use to work problems a lot of times. So how many grams of sodium hydroxide are needed to prepare 75 grams of a 14% mass sodium hydroxide solution? All right, what do we know? Okay, let's see. We're going to make 75 grams of this, okay? It's 14% mass. So that means that we have 14 grams of sodium hydroxide per 100 grams of solution, right? So those are the two facts that this actually gives us. All right, so if we have if we want a 14%, but we're only going to have 75, okay, so what do? Think about it for a minute. One easy way you could do it is to say that if you have a 14 grams and 100 grams, that would be the same as what over 75 grams. Okay, and so then you'd cross multiply to have 100x equals whatever 75 times 14 is. If I can find my calculator. Which is 1,050. And so x would be 10.5 grams. Okay, I mean that's a ratio proportion. That's just a quick way to do it. You can also use it by using the conversion factor. You've got 75 grams of solution. You know that you want a 14 gram per 100 gram, and so you can cancel those grams of solution, and that will also give you that answer. So it takes 10.5 grams of sodium hydroxide to make 75 grams of a 14% mass concentration solution. How many milliliters of a 5.75 volume ethanol solution can be prepared from 2.25 milliliters of ethanol? You got 2.25 milliliters of ethanol, and then what conversion factor does that give us? Well, you know you're going to have methanol, milliliters of methanol on the bottom, So you're going to have solution up here, right? So this is per 100 milliliters, right? And so you want a 5.75%, so it's 5.75 milliliters per 100 milliliters. And so 2.25 times 100, then divided by 5.75. That should be about 39.1 milliliters of solution. How many grams of aluminum chloride are needed to prepare 125 milliliters of a 0.150 molar solution? All right, start with what you're given. 125 milliliters times this is 0.150. M is the same as what? Moles over liters. So 0.150 moles per 1 liter. Okay, and 1 liter is the same as what? 1,000 milliliters. So if you want to, just skip a conversion step and you know that, then that way you can get rid of the milliliters. And so you got 125 times 0.150 is 18.75 divided by 1,000 is equal to 0.1875. Wait a minute, that's not one of the answers. That's because what are my units? Moles. So 0.1875 moles. And then I'm going to have to get what? The molar mass of that. So if you'll excuse me, I'm going to the next screen because they will have that for me. So 0.125 liters, or you could have kept it in milliliters if you want to, times 0.150 moles, times the mass of aluminum chloride per mole. Cancel, 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 cancel. Gives you 2.50 grams of aluminum chloride. Alright, we had to do some math in that one, but that's alright, we got through it. So practice these. You should have some mastering questions. There's some in the back of the book with some of the answers that you can look up. It's important that you get this because you're going to use these calculations, especially in healthcare, quite a bit. And so solutions are a really important aspect to get your mind around. Alright, thanks for your attention, and I will see you again in 7.5.